Hi there, all you processing users. This is John Park from the University of Oregon, and today I'm going to be talking about perhaps one of the more confusing things for beginner to intermediate processing users, which is the push and pop matrix. Both of these terms, push and pop matrix, they sound really scary and a bit confusing, but really once we get into it, we'll realize that it's not that tricky, more importantly, these two terms will help us manipulate and change around a lot of imagery and other things. So the best way to begin to understand this is to perhaps start with the sketch, and I'll leave a link for this sketch down in the comments of this video. But this is just the beginning sketch. All I have here is a P image. This is just an image that I'll be loading into my sketch. It's called grid.jpg. If I were to go and look at what this is, grid.jpg looks just like this. I just created this grid in Photoshop. It's 800 pixels wide by 600 tall. And just so we understand where the origin point is, or the 0, point is in processing, I just put that just in this image up at the top left, this kind of red dot. So I'm taking that JPEG, loading it into this sketch, and the only thing that's happening in the sketch is just drawing a white background and then drawing that image at 0, or the top left. So if I run this beginning sketch that you're welcome to kind of start with, essentially that image is filling the screen. Now, the reason why we'd want to get into push and pop matrix is if you want to do some things, specifically usually rotating or scaling or translating, which is the same thing as moving elements around in your sketch. So, for example, if I had this image here and I wanted to use the term translate. Okay, translate again is the same thing as move. And anytime you're working with a term, if you're unfamiliar with it and it turns blue, if it's a built-in term, you can always select the whole thing, right-click on it, and say Find in Reference. Then a web page will pop open with the reference for that specific term. So here it says specifies an amount to displace the object within the display window. So this is really what most people would think of as moving. So I could translate this whole certain objects or an image by a certain amount. So I'll say 300 pixels over, 300 pixels down. I'll put in these two values. First is the X, second is the Y. Now whenever you use translate or rotate or scale, it's going to affect everything in the sketch below that term. So if I had an ellipse above this, and I drew that out and then did a translate after, the translate would not move the ellipse that was before it. It would only move the stuff after. So now that I put this translate of 300 to 300 and I'll run the same sketch, this will just kind of get us to understand, oh, okay, the whole grid, including what processing thinks the 0, point is moving 300 pixels to the right and 300 pixels down because we put that translate in. So the really important thing to remember is that the whole internal coordinate system for processing now got shifted by 300 by 300 pixels. If I were to draw an ellipse that was located at 0, and was 100 pixels wide and 100 pixels tall, and I were to run that, this is where the ellipse goes. And you might think, well, no, wait, I thought in processing 0 is always at the top left. And that's true normally, but because I translated the sketch by 300 pixels over and 300 pixels down, it's actually now all of its internal coordinate systems are off by that 300 by 300 pixels. So now everything is kind of thinking that 0 is right here. Now this is really, really useful for some types of things, but it's also kind of problematic because maybe you only want to move one object down, but then now you really want to kind of get stuff oriented back to the top left. Well, if you were really kind of weren't doing too many things, you could say, well, I could draw my ellipse at negative 300 by negative 300 and, see how that works. Well, okay, now that's working again, but that gets really confusing because every time you rotate or translate or scale something, you'd have to kind of undo all that action in your head or by keeping track of it all. There's a much better way to do this. And the idea here is that we could do what's called the push and pop matrix. So if we think about the translate in this case, throwing off our coordinate system and moving all of it from this point downwards in your code, everything gets moved over and down. The way to kind of undo that or just have that be temporary is to think about saving the coordinate system into a buffer. So it's going to be essentially storing what was happening before we use the word push matrix. Push matrix. And every time you use the word push matrix, we're going to do a pop matrix after it. So the idea here is that I would say push matrix, do the stuff that I want, most importantly the translate or a rotate or a scale, and then afterwards I'd say pop matrix to essentially end this. So this is kind of starting, remembering the buffer of where things used to be located, and pop matrix is restoring back to that point, which is to say that this translate will kind of get ignored outside of the push and pop matrix. So I'll go ahead and do this. Now, if I do that and I bring I essentially will draw a rectangle now back at 0, 0 again, and I run that. Okay, it did move. Okay, so like here it's storing what the coordinate system is, which is the 0, 0 being at the top left. Then it's moving the whole sketch over 300, down 300, drawing an image at 0, 0. So that's why we see this picture drawing out here. But then the pop matrix is saying, hey, let's return the coordinate system to where it was. So now 0, 0 essentially gets moved back to where it used to be, which is at the top left. And now we draw the ellipse at 0, 0. Okay, so that's kind of like refreshing or returning stuff to its native state. Now this is particularly important, not necessarily with a simplified sketch like this, but if you do a lot of different things. Now let me show you one particularly useful or kind of important way in which you use this. If I had if I were working in a three-dimensional space, such as, actually let's not even do P3D, let's just talk about rotation, right? If I were gonna rotate something in my scene, and I'm gonna kind of, for now, comment out with 2 slashes, comment out the push and pop matrix. Instead of translating my sketch, if I were gonna rotate my sketch, when you use rotation, it's gonna wanna rotate your whole sketch by a certain number of radians. Now 2 times pi radians is a full circle, or what we'll think of as 360 degrees. If you think only in degrees and not in radians, there's a really shortcut way to do this, which is to type in the word radians, and anything between 2 parentheses, after you use the word radians, will convert degrees into radians. So let's say I want to rotate my whole scene by 35 degrees. I can do that. 35 degrees, I put the word radians in here, now it's going to convert 35 degrees to whatever the equivalent is in radians, and then it's going to rotate the whole sketch by that. Now I have my image here happening at 0, 0, so I'll go ahead and just run this. I commented out the ellipse, I commented out the push and pop matrix, and let's just see what this looks like. Okay, so this is a 35-degree angle between this horizontal line and this. So that looks right. But the weird thing here and the important thing to know is that processing always wants to rotate stuff around the origin point, or 0, 0. So that's why it shows the top left as the thing that it rotates around. If I said 75 degrees here that it's rotating by, and rerun, okay, there's a much steeper angle. Okay, 75 degrees between horizontal and this. So that's all good and fine, but you might say, well, what if I want to rotate around the center of an image? How would that work? Okay, or even more importantly, what if I want to essentially be rotating around the top left of a picture, but have that rotation, that kind of pivot point around the rotation happening somewhere else in the screen? Now this is where we can get into combining 2 different transforms. I could combine a translate as well as a rotate. So if I were to first translate the whole sketch, including spelling it correctly, and I was going to translate it by my mouse position, I could just say mouse X and mouse Y. So now it would essentially, the whole sketch would follow where my mouse is. And it's going to be moving the top left, or the 0, 0 coordinate system now, to the X position and Y position of my mouse. So it'll do that first, and then it's going to rotate, and then it's going to draw the image. So let's just go ahead and do that. Okay, so first it moved the sketch to where my mouse is, then it's rotating it by 70 degrees, and then it's drawing the image at 0, 0. So By doing that, that's all good and fine. Now again, the problem with this whole system is that if I were doing some other image or some other shape, let's say I draw an ellipse at 400 pixels by 300 pixels, I would normally think that that ellipse would just get drawn at 400 by 300. But look what happens. Okay, the ellipse is moving with my image here. It's kind of stuck down there. Why? Well, the reason is that the whole sketch is being translated by this amount and everything below this is translating with it. So if I don't want that, if I want to kind of just keep this rotation and translate sort of just affecting one thing, such as this image grid, I could comment out the push and pop matrix, rerun the sketch, and now look what happens. This ellipse now is drawing at 400 pixels to the right, 300 pixels down, and it's not subject to the translate and the rotate, which is fantastic. That's what we want. One more quick little side note about this. If I wanted to, for example, have this image spin around and not just statically be stuck here, we could essentially have it rotate by a value that's growing, right? Just imagine a clock would rotate by 1 degree, 2 degrees, 3 degrees, and that number of rotation would be constantly incrementing or growing. You could do something like that if you want relatively quickly here. At the top of your sketch, if you just make a new variable, and I'm going to say it's going to be a float type of variable, that's a number that is a mixed number or a fractional based number. I could say I'm going to call this rotate val, and I'm going to start it at 0.0. Then in the void draw at 60 frames a second, I could make rotate val grow by just a very small amount. So I'll say at the very top here, rotate val plus equals 0.02. And if you've never seen plus equals before, that's the same thing as saying rotate val equals rotate val plus 0.02. These two things are doing the exact same thing. So if rotate val starts at 0, we're saying 0, or rotate val equals 0, which is it currently is, plus 0.02. So would every frame go 0.02, 0.04, 0.06, 0.8, 0.1, 0.12, 0.14, etc. So anyways, this is the shorthand way. It'll save you a lot of time once you get used to doing the plus equals. Okay, so now at 60 frames a second, I have rotate val growing by this amount. And now when I actually have this rotation value, instead of rotating by this fixed number, which is 75 degrees, I could just rotate by rotate val, okay, which is growing slowly but surely in radians here. Okay, and as I bring my mouse, now we have that spinning around. A lot of students end up asking me, well, okay, it's rotating around the center point. Usually not what we want. If you want something to spin around, maybe you want it to rotate around the center of the image instead of the top left. Well, that just all has to do with image alignment. And you can set this up in image mode if you want. If you want it to happen throughout your whole sketch, you could just say image mode, and then in parentheses, all in caps, just say center. Now it's going to think, if it wants to draw the image at 0, 0, it's going to think that the image will get oriented from the middle instead of the top left. So image mode center will do this. Here now I can see it rotating around the center point, and so on. Good. So there's the push pop matrix at work. One of the final little kind of bonuses here I wanted to show people is that when you're working in 3D space, this becomes particularly important. So you may or may not have looked into P3D, but P3D is another rendering engine. By default, everything will render in processing in 2D, kind of flat planar work. But if we say in our size call up here, sort of this declaration of the size, after you do the X and Y, the width and height of your sketch, if you put a comma and say P3 and D, capital letters, now it'll let us do things like rotate not just in the top-down view, but we can rotate three-dimensionally. So this is most often used, not so much for drawing an image, but rotating things like maybe text. And people rotate images too. But let me just show you here how this would normally work. If I were going to draw a piece of text that had my name, text quote mark John Park, and I wanted that to be over here drawn at 300 pixels down, or 300 pixels over and 200 pixels down. A normal sketch would probably do this. And let me just first, I'm going to get rid of all this stuff to begin with. Okay. All this sketch is doing is drawing a background. And in fact, let me just even get rid of the push and pop matrix. There we go. We're really just drawing a piece of text. Let me go ahead and run that. We can't see the text because the fill is set to white text on a white background. So here I'm just going to say fill 0, which would just be black. Okay, there's my name, John Park there. If I want that to rotate, maybe like twist around itself and look like it's spinning, okay, I might normally think, oh, okay, well, hey, we have this rotate thing over here. What if I comment out the rotate and I continue to do this rotate val thing, this thing where it'll kind of grow in rotation. Now, like I mentioned, now that we're in P3D, we can rotate not just in the normal rotational axis, which is called the z-axis, but I could rotate in the y-axis too. And that should make it kind of spin around like a turnstile. So let's go ahead and run that and see what happens. Okay, there I see it. Hey, yeah, it's rotating, but wait a minute, what's it doing? Why is it spinning around this point? Okay, and the reason why is it's wanting to rotate on the x across its origin point. Remember I mentioned 0, 0 up here. Now that means if we say rotate in the y-axis, it's choosing this vertical line here to rotate around, which is a little odd, right? Maybe kind of problematic. Pretty soon here, we're going to need to use push and pop matrix to kind of fix this. Okay, now one possible solution is to say, well, if the distance in this x-axis for where that text is being drawn is essentially determining how wide the orbit is around this vertical line, then when I draw my text in the x-axis, instead of 300, what if I say 30, right? And I rerun that. Okay, well now, this is 30 pixels away, and now it's spinning around this point. Okay, so that's getting closer. You could say, well, what if I really want it to spin around itself, like the space between the word John and Park, what if I want that to be the rotation point? Well, then we get into some kind of funny territory, where I'd probably want to actually align the text, like center justify the text, because right now by default it's left justifying the text, and I'd probably want to draw it at 0, 0. So let's do those two things. First, just like we did the image mode center in the void setup, I can say text align, this is a built-in term, center, just like image mode, and now when I run that, it's going to choose 30, 30. Essentially this would be the center point of where the text is drawing, and now it's still rotating around this axis. And then I'd probably want to, when I draw the text, draw it in the x-axis at 0. Okay, so now I should just be seeing the word park initially, and then it's spinning around that point. So we're getting really close, okay? And so some of you might say, well, what if before you rotate this thing, we just put our translate back in? Like if we want it to be attached to our mouse and rotating around, well, there we go. We're getting closer. It's sort of vertically offset from the mouse. That's kind of weird. Well, that's just because when we're drawing the text, it's drawing it at 200 pixels down from the origin. But our mouse is located at the origin. So that's why this is shifted, this piece of text is shifted 200 pixels down from the mouse. So if I draw this at 0, 0, there we go. That's looking better. But that's all good and fine. Now we have this three-dimensional rotating piece of text. But if I want to do anything else in the scene, right, this might just be part of a program I'm writing. I might want to do some other stuff after this. Like, hey, I want to draw a big rectangle after this. That's located at 200 by 200. It's 400 pixels wide and 35 pixels tall. The same kind of problem could come up here. Like, oh, shoot, you know, that's maybe not what I intended to happen. Okay, I don't want that big black rectangle flipping around just like my text is. Hey, let's come back to the push and pop matrix. Okay, once again, we'll just put the push and pop matrix in there. And Now, only this section will happen between the push and pop matrix, the rotation, the rotate, and drawing the text. And now everything else will kind of snap back to its normal coordinate system. There we go. Visual element in the middle there, and our text being drawn. So hopefully that helps kind of clear up how that push and pop matrix is. I really do think that using that image with the grid is one of the biggest secrets to understand, like, oh, that's internally how processing is thinking about its own coordinate system. So I hope this helped. Good luck to everyone, and we'll see you next time.